Hiya, how's it going? Right, in this video I'm going to look at differentiating the inverse trigonometric functions, so arcsine, arccos and arctan. Okay, so differentiating y equals arcsine x, arccosx, arctanx. Now what I'm going to do for this video is, because the method is exactly the same for all three of these, I'm going to do them simultaneously. Okay, so I've got them lined up with the working already filled in. That's mainly just to cut the runtime of this video down, okay, and to show you just how really similar these methods are for any of the inverse trigonometric functions, okay. By the way, you can also use the same method for differentiating arcsec, arccosec and arctan. So arccot. I don't have those videos, but yeah, you can actually do them in a similar way to this. Right, the method is, because we don't yet know how to differentiate arcsine, we're going to rewrite it with x as the subject, okay? Because we do know how to differentiate sine. So what we do is we're going to write as x equals sine y. I'm hoping you're understanding that. Because arcsine is the inverse of sine y, rewriting it, you've got sine y equals x, or x equals sine y. And the same with this then. We're going to have x is equal to cos y, and then we're going to have x is equal to tan y. Okay? Right, next, we're going to find dx dy. Why is that? Because we've got x in terms of y, and when we're differentiating, if we're differentiating x in terms of y, we're finding the rate of change of x with respect to y, so that is dx dy. So dx dy, differentiate with respect to y, differentiate sine, you get cosine, so it'll be cosine y. Here, dx dy, you're going to get negative sine y, and then here, dx dy, do you remember what that one is? Yeah, sec squared y, isn't it? Okay. Next, because we're trying to find dy dx, the next simple step is take the reciprocal of these. So the reciprocal of dy dx will be 1 over cos y, reciprocal there. Dy dx will be negative 1 over sine y, and here the reciprocal is going to be 1 over sec squared y. Resist temptation to write this as cos squared y, okay, because it's not going to work out for you. All right. Yes, you can write that as 1 over cos squared, and the reciprocal is just cos squared, but trust me, it's going to be easier to write like that, okay? If I remember, I'll try and give you the reason why I don't want to write it as cos squared y. Right, what are we going to do next? Here's the more challenging bit, I suppose, okay? But something that's got to come second nature to you, particularly with a topic like parametric equations coming up, okay? You've got to be able to rewrite this in terms of x, because when we're differentiating that, we want to find dy dx in terms of x, and at the moment we've got dy dx in terms of y. So you've got to write that in terms of x, not y, and that's the hard bit. We need this because this is the relationship between x and y. It tells us that x is equal to sine y, and at the moment we've got cosine y. So we've got to find the way of writing cosine y as sine y. Have you got it? We've got to try and find a cosine y and write it in terms of sine y. Well, that's just going to be root 1 minus sine squared y, because of the identity cos squared y plus sine squared y equals 1. You can use any letter, cos squared theta plus sine squared theta equals 1. So cos squared y is 1 minus sine squared y, and cos y will be root of that, root 1 minus sine squared y. Same with this. Okay, so sine y, that's going to be root 1 minus cos squared y, so don't forget negative 1 over root minus cos squared y. Now for this one, that identity is not going to work, okay, because our relationship is x equals tan y. So we need the relationship between tan and sec. And of course that relationship is sec squared y is 1 plus tan squared y. Now going back to what I said earlier, that's why if you write that as cos squared y, you're going to run into a bit of a mess. Okay, run into a bit of a muddle. Okay, because you're not going to find an easier relationship to find what cos squared y is in terms of x when x equals tan y. See what I mean? The relationship between this and this, using identity, you can neatly write it in, okay? You can still do it, but it's a lot more fiddly, okay? So write it like this, okay? Right, final step, we want to write it in terms of x, don't forget. So sine y is x, so sine squared y is x squared. So that is just x squared. So our answer is 1 over root 1 minus x squared. Similar with this, cos y is x, so cos squared y is x squared. So that is going to be negative 1 over root 1 minus x squared. And finally, because we've got tan y is x, tan squared y will be x squared. There's no root there, notice, okay? That's just going to be 1 over 1 plus x squared, okay? And that is it. I'm going to move out of shot, just so you can see that in case you wanted to take a screenshot of my lovely work. But that's it. That's differentiating inverse trigonometric functions. Hope you enjoyed that. Hope you got something useful from it as well. See you again soon.